Far away on an island, an old enemy arrives, spreading silently from one person to another with just a cough or a sneeze. Once inside, it hides, waiting, dormant. The body's immune system holds it back, but when its defenses falter, it awakens, multiplying, spreading, filling the lungs, sometimes even the kidneys or bones. This old enemy is none other than tuberculosis, or TB, caused by the mycobacterium tuberculosis. Visible symptoms appear as coughing and chills, but then a loss of appetite and blood starts to appear in the cough. Without intervention, it can lead to death. The battle against TB has been long and deadly. According to the World Health Organization, more than 1.6 million people fall ill with TB each year, and about 1.3 million die. In developed countries, scientific advances have slowed its spread, but many developing nations still struggle with TB and its effects. Treatment for active TB can last 3 to 9 months with antibiotics like isoniazid and parasitamide with an 85% success rate. Drug-resistant TB requires longer, more expensive, and more toxic treatments. In some countries, up to 50% of TB-affected households face catastrophic costs, losing over 20% of annual income to treatment, travel, and lost work. Latent symptoms and long incubation periods of the bacteria means that people are less likely to test. Furthermore, TB divides unequally, leading to drug-resistant strains. Because of these challenges, the United Nations included TB in its Sustainable Development Goal 3, ensuring health for all. A key focus, SDG 3B, focuses on supporting research for vaccines and medicines and making them affordable worldwide. The most effective vaccine to date is the BCG vaccine, made 100 years ago. It is typically given to children, but the efficiency of vaccines declines with age, and it doesn't fully stop infection, instead only reducing the chance of the disease developing. The evolving new strains of the TB bacteria causes time constraints for the production of the BCG vaccine. But good news arrives with the potential of mRNA vaccines.
mRNA vaccine works by delivering synthetic mRNA inside lipid nanoparticles, or LNPs. These LNPs protect mRNA from degradation and delivers it into the cells where it is translated into TB antigens. These antigens stimulate the immune system to activate both Th1-CD4 plus T cells, which kills infected cells, and B cells, which produce antibodies. LNPs can also enhance the immune system. Recent research on the new LNP mRNA TB vaccine called mRNA CV2 shows it can generate high frequencies of polyfunctional Th1-CD4 plus T cells, reduce bacterial load, and limit lung inflammation in mice. When used as a booster after BCG, it provided stronger and longer-lasting protection than BCG alone. Other studies using combination of TB antigens have also shown strong immune response and improved protection when paired with other vaccine platforms. Zebrafish are also being used in TB research because they share around 70% of human genes and form granulomas, similar to when infected with the TB-like virus. As larvae, zebrafish are transparent, allowing scientists to directly observe infection, latency, and reactivation, making them ideal for rapid, cost-effective vaccine testing. An mRNA vaccine has several advantages. They can be redesigned in weeks if a new TB strain emerges. They can use the same production system that exists for COVID-19 vaccines. They are non-infectious and suitable for immunocompromised individuals. New facilities in Africa will allow local manufacturing to lower costs and improve access. Before an mRNA TB vaccine becomes widely available, we still need human trials, long-term immunity data, thermostable formulation to avoid deep freezing, and strong public trust in vaccination programs. If successful, this vaccine could prevent millions of cases, save billions in healthcare costs. This would help achieve the World Health Organization (NTB) strategy goal of reducing TB deaths by 90% and cases by 80% by the year 2035. TB has been with humanity for centuries, but with molecular biology tools like mRNA vaccines, we have a real chance to finally control it and make SDG 3.B a reality.